Ever find yourself scrolling through social media, using those fun photo filters? Or maybe you deposited a check using your phone.
Or even something as simple as unlocking your phone with facial recognition.
Exactly. Bet you didn't realize you were tapping into the work of today's deep dive subject, Yann LeCun.
Yann LeCun, the godfather of deep learning. His fingerprints are everywhere in today's tech landscape.
Okay, so we've got our work cut out for us here. We're diving into the life and work of a guy whose research is basically the engine behind how computers are starting to, see the world.
And it's a fascinating journey, really, from his early days in France, tinkering with electronics, to his current role at the forefront of AI research.
Right, so no time to waste. Let's get into it. Where do we even begin with a guy like LeCun?
Well, I think the best place to start is with understanding the core of his work, deep learning. It's a field that's absolutely exploded in recent years, and LeCun's been there since the very beginning.
Okay, so back it up for me a bit. Deep learning, neural networks, it can feel like we're throwing around buzzwords. What's the layman's version here?
You got it. Imagine you're trying to teach a computer to recognize a cat in a picture.
Okay, sounds simple enough.
Not really. See, traditional computer programs, they need very specific instructions. So you'd have to tell the computer to look for pointy ears, whiskers, a tail, all those features.
And that's a lot of coding, I imagine, for every single variation of what a cat could look like.
Exactly. And even then, it might miss a cat that's curled up or partially hidden. Now, deep learning, that's different. Think of it like this. Instead of giving the computer a list of features, you feed it thousands, even millions of images of cats.
And it learns from those examples, like training a dog with treats, but with data.
Precisely. The neural network, which is loosely inspired by the human brain, starts to pick up on the patterns, the subtle nuances that make a cat a cat. And the more data you feed it, the better it gets at recognizing cats, even those tricky, partially obscured ones.
Okay, I'm starting to see how this is a game changer. But how does LeCun fit into all of this?
Well, he's one of the pioneers who made this all possible. Back in the 80s, he was already developing algorithms that would allow these neural networks to learn effectively. One of his key contributions was something called backpropagation.
Backpropagation. Sounds complicated.
It's a mouthful, but the concept is pretty intuitive. Imagine you're taking a test. You get a few answers wrong. What do?
Study harder. Focus on what I missed, obviously.
Exactly. Backpropagation is similar for neural networks. It allows the network to learn from its mistakes by adjusting how strongly different connections within the network are weighted. Each time it gets something wrong, it goes back and tweaks those connections, so next time it's more likely to get it right.
So it's constantly learning and refining its understanding.
Exactly. And this breakthrough, which LeCun was developing during his PhD in the mid-80s, was a pivotal moment for deep learning. It laid the foundation for the incredible progress we're seeing today.
And it wasn't just theoretical work, right? He had that groundbreaking check reading system too, which I have to admit sounds kind of, boring at first glance.
I know what you mean, but trust me, back in the late 90s, this was revolutionary. LeCun's check reading system, using his early neural networks, was processing a huge key chunk of all checks in the US.
Hold on, so you're telling me that those little machines at the bank reading my handwriting, that was LeCun's doing?
In a nutshell, yes. Back then, getting a computer to recognize handwritten characters, it was a huge technical hurdle. But LeCun's system did it with impressive accuracy. This wasn't just a cool tech demo. It was a real-world application that impacted millions of people.
Okay, I take back my boring comment. That's actually pretty impressive. He saw a problem, a very practical problem, and used this cutting-edge technology to solve it.
And that's always been a hallmark of his work, bridging the gap between theory and practical applications. But where he truly changed the game was with convolutional neural networks, or CNNs.
All right, CNNs. Hit me with it. This is where things get really interesting in the world of AI and computer vision.
Absolutely. CNNs are ingenious because they're modeled after how our own brains process visual information. Think about how we recognize a face. It doesn't matter if the person is looking straight at us or turned slightly away. Our brain just gets it.
Yeah, we don't even think about it. It just clicks.
Right. CNNs work similarly. They can analyze images and detect objects regardless of where they are in the image or even if they're partially hidden.
So it's not just matching pixels like a basic computer program. It's understanding the actual structure, the essence of the image.
You got it. That's why CNNs are so powerful for tasks like facial recognition, image classification, even self-driving cars. They can process and understand visual data in a way that was previously unimaginable.
And this was all LeCun.
Well, he's credited with laying the foundation for CNNs. His work in the late 80s and early 90s, it revolutionized the field. It's no exaggeration to say that CNNs are one of the key reasons why AI, especially computer vision, has advanced so rapidly in recent years.
It's mind-blowing when you think about it. But hold on, we can't forget about DJ Vu. I mean, who remembers those days of waiting, like an eternity for scanned documents to download?
Ah, yes, DJ Vu. It might not be as flashy as some of his other work, but it's a perfect example of LeCun's ability to apply his expertise to solve real-world problems. His work on image compression with DJ Vu significantly sped up how we share and access scanned documents.
It's funny how something we take for granted now, like downloading a research paper in seconds, was once a major technical hurdle.
And that brings us to what's so exciting about LeCun. He's not one to rest on his laurels. Even today, he's at Meta, pushing the boundaries of AI research.
Okay, so from reading handwritten checks to revolutionizing computer vision, where does he go from there? What's he working on now?
Well, one of the things that really excites him is self-supervised learning. You see, right now, most AI systems, they need to be fed tons of labeled data to learn.
Labeled meaning we have to tell them exactly what they're looking at, right? Like this is a cat, this is a dog, and so on.
Exactly. It's a very labor-intensive process. But LeCun, he envisions AI systems that can learn from raw, unlabeled data, much like how humans learn.
So a computer that can learn by just observing the world, making connections, just like a child would. That's pretty ambitious.
It is. It's about creating AI that's less reliant on curated data sets and more adaptable to the messy, unstructured, real world.
And this kind of research, it has implications for just about every field imaginable.
Absolutely. From healthcare to finance, transportation to entertainment, the potential of AI to transform our world is immense. And LeCun, with his relentless pursuit of knowledge, his ability to bridge the gap between theory and practice, he's one of the key architects of this future.
It's almost like that line between science fiction and reality. It's blurring more and more each day.
And that's what's so fascinating about LeCun's story. He reminds us that even the most complex technologies, they stem from human curiosity, from that drive to explore the unknown.
Well, on that note, as our deep dive into the world of Yann LeCun comes to a close, it leaves me with one big question. What will he and his fellow AI pioneers unveil next? And how will it reshape our world? Something to think about.